Hi everyone. So previous to this practice problem, we were using memorized forms for exponential and logarithmic functions. And now we're kind of back to the U substitution problems. So we have a definite integral here, and I'm going to rewrite this. We're going to bring the 20 out in front. We're going from 0 to the natural log of 4, and I'm going to write this as 1 over the square root of 10 plus e to the 4x times e to the 4x dx. And now we're going to let u be that inside function of 10 plus e to the 4x. And so we have that du equals, don't forget the chain rule here, this is going to be e to the 4x times 4. I'm going to put the 4 out in front, dx. So I'm going to divide both sides by 4 since I really don't want it. I want just a plain e to the 4x dx. And then we also have to change our limits of integration. So when x equals 0, that means u will be 10 plus e to the 4 times 0. Anything to the 0 power is 1. So this is going to be 10 plus 1 or 11. And then when x is equal to the natural log of 4, we'll have u equal to 10 plus e to the 4 times the natural log of 4. Well, this takes a little more work if you remember the rules of logarithms. So this would be the ln of 4 to the 4th power. But now the e and the ln cancel out, and I'll have u equal to 10 plus 4 to the 4th power. And when you put that in your calculator, you will get 266. Which means that when we go back and do our substitution, we'll have 20 times the integral from 11 to 266 of 1 over the square root of u times 1/4 du. I'm going to bring that 1/4 out in front. When we divide 20 by 4, we'll get 5. And I'm going to rewrite the square root here as u to the negative 1/2 du, so I can use the power rule. So we'll increase the power by 1, giving us a u to the positive 1/2, and then we'll divide by 1/2, which is the same as multiplying by 2. And we're going to evaluate this from 11 to 266, giving us 10 times the square root of 266 minus the square root of 11. And I think you can leave that in its exact form. I don't have any directions for this problem on whether or not I should round it, so I'm going to leave it like this.